Hi there, my name is Saeid. I'm with Prep 101. In this primer, we will talk about basic derivatives and derivative formulas. You need to be familiar with some basic derivative formulas from high school in Math 1ZA3. You will also learn the applications of those derivatives and how to use those derivatives to evaluate limits later in the course. Okay, let's get started.
Here are some basic derivative formulas that you need to be familiar with. So if I have a constant, the derivative of that is equal to 0. If I have a constant multiplied by a function, I can factor out the constant, take the derivative of the rest, and multiply the constant back. I don't need to use product rule. When it comes to sum and difference, you can take the derivative separately and just add and subtract the terms. The product rule is used when you have a multiplication of two functions and you want to take the derivative. So that will be the derivative of first times second plus derivative of second times first. The quotient rule is here. That's when you have a division of two functions, and you're going to use this rule that involves a fraction to take the derivative of a quotient. The chain rule is when you have a composite function. So you have a function inside another function. So basically what you do, you take the derivative of the inside function with respect to x, that will be du dx, multiplied by the derivative of the outside function, so dy du or df du. We're going to do some examples so you will see how they are used. Now there are some more formulas here that includes the logarithmic function, so the derivative of ln, which is 1 over x, derivative of log, which is 1 over x times ln a at the bottom, exponential, which is e to the x, and if you have a general exponential function like 5 to the power of x, the derivative of that would be 5 to the x times ln of 5. These are the derivative of trigonometric functions. So sine, the derivative is cosine, tan, the derivative of secant squared, and this part that you see is because of the chain rule. So if this u itself has a derivative with respect to x, you have to multiply your function by that. And down here you have the derivative of inverse trigonometric functions. Sine inverse, cosine inverse, tan, cotan, and secant inverse. Now let's do a number of examples. Example 1. We want to find the derivative of, so find the derivative of the following functions. So in part A, we find the derivative of x times 10 to the power of x. So as you see, I have a product of two functions, and if I want to take the derivative of this and write f prime of x, that will be the derivative of the first, which is just the derivative of x, that's 1, multiplied by the second, so that's times 10 to the power of x. I'm using product rule, plus the derivative of the second, so that is 10x prime multiplied by the derivative of the first. And this, in the next step, I can focus on the derivative of 10 to the power. So the first one is just 10 to the x plus the derivative of 10 to the power of x. It's an exponential function, but it's the general form. So that would be 10 to the x multiplied by ln of 10. And that would be multiplied by x. So I can factor it out if I want to simplify it a little bit. So I can factor 10 to the x. That will be 1 plus x ln 10. So this is the derivative of this first function. The second question, or part B of this question, we want to take the derivative of ln of sine x. So if you have ln of something, you know that ln of x, if you have ln of x by itself, and let me write the formula on the side. If you have ln of x by itself and you take the derivative, it will be 1 over x. But if you have ln of something, if you have ln of some stuff here, and you want to take the derivative of this, but that's actually a little bit different. You have to use the chain rule. So it will be 1 over that. That's the formula for ln. And obviously, because of the chain rule, we have to multiply it by the derivative of itself, by the derivative of stuff. So that will be the derivative of this in front. Well, I can simplify this formula and then just put this derivative on top and this term at the bottom. Now, this is a general formula you can use for the derivative of ln of something. So in this case, if I'm looking for ln of sine x, I can draw a fraction line. I can put the derivative of this stuff, which is sine x, on top. So that would be the derivative of sine x on top, and then just sine x at the bottom. the derivative of sine x would be cosine x, and then I have sine x at the bottom. So this becomes cotan x. So the derivative of this function would be cotan x after simplifying. Another example. We want to take the derivative of secant squared x plus tan squared x. So if I want to take the derivative of secant squared, I need to use the chain rule, because technically we have the derivative of something to the power of 2. Well, I know how to take the derivative of x squared. That will just be 2x. But in this case, we don't have x squared. We have something else squared. Again, we use the general form, which is 2 times that. That's just the formula of the power formula, x squared 2x. And then because we are using chain rule, because we have something, we have the stuff, we have to multiply it by the derivative of that. So that means we will do h prime of x. The derivative of this would be 2, and then secant x multiplied by the derivative of secant x. For now, I can just write derivative of secant x. And I need to do the same thing with that tan. So that would be 2 tan x, which is 2 minus 1, or to the power of 2 minus 1, multiplied by the derivative of tan x. So let's continue. In the next step, I will do the derivative of secant x. The derivative of secant x, according to the formula, is secant x tan x. And that would be 2 tan x. And here I have the derivative of tan x. So the derivative of tan x is secant squared. So secant squared of x. And I just need to simplify this a little bit. So 2 secant squared of x tan x plus 2 tan x secant squared of x. Well, if you look at these terms, you notice that they're kind of identical. So I can just add them up. That would be 4 secant squared of x times tan x. This is considered a simplified form, but obviously you can use some trigonometric identities to write secant squared in terms of tan as well. So these are some examples on derivatives and how to use product rule and chain rule and constant in your derivative.
I hope that you found this useful. If so, check out more foundations of first year calculus in the playlist. Also, make sure to join our Facebook Study Hub for this course. You can find the link in the description box below. Finally, I hope to see you at my prep session. I will show you how to solve midterm and exam problems and how to do that with confidence and how to ace your midterm and exam. Remember that many prep sessions for midterms are free. Visit prep101.com for more details. Thank you for watching.